Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to all students. My name is Dr. Sharif Fauzi Kamaruzaman and today I would like to continue the course for Data Communication and Networking under Module 12 IPv6. Thank you for all of you who have already subscribed for me, and for those who have subscribed for me, please do drop some likes on my videos, and for those who haven't subscribed, please subscribe my channel. It will be good for you to continue with me later on in the future, since I will upload more video later on in the next time. So let's start our class for today. So basically today our topic will cover under IPv6. So let's start our class for today. IPv4, okay, as you guys know, it's created out of 32 bits, four sets of 8 bits, which is total at 32 bits. So the problem with IPv4 that we have right now is that the number of IPv4 is getting depleted day by day. So we need to have an extra IP address in order to fulfill all the requirement that in the future we might have, like for example more numbers of mobile phone. We have a lot of more numbers of PCs. We have technologies like IoT that require things to have IP address as well. So this become problematic to all of the service providers, since they could not have IP address allocated to those equipment, enough for those equipment. So in this case, okay, if you see at the figure that I showed here, okay, like for example in North America, they expect to exhaust the IPv4 address by July 2015. Okay, in Latin America, you have around April 2011. Okay, in Europe around September 2012. Okay, in Asia you have 2014, and in Africa you have around 2020. Okay, so the problem with IPv4 is that they are running out of address, and therefore they create what we call IPv6 as a successor to the IPv4. So IPv6 they has a much larger 128-bit address space. Okay, so comparing to IPv4, they are way 4 times larger than the normal IPv4. So the development of IPv6, okay, also included fixes for IPv4 limitations and other enhancement as well. So with an increasing internet populations, a limited IPv4 address space issues by the NET and the IoT, the time has come to begin the transition to the IPv6. Okay, so most of our computers and our smartphones these days, okay, they will be transitioned towards the IPv6. Okay, so basically when we see at IPv4 and IPv6, both IPv4 and IPv6 will coexist in the near future, and the transition will take a little bit longer than we usually thought. Okay, the IETF, they has created various protocols and tools to help network administrator migrate their network to the IPv6. So these migration techniques can be divided into 3 categories that you see in your slides right now. Okay, so the techniques that we have for migrating for IPv4 and IPv6, okay, first we have the dual stack, okay, which the device run both IPv4 and IPv6 protocol stacks simultaneously. Okay, next we have tunneling, which is a method of transporting an IPv6 packet over an IPv4 network. Okay, so the IPv6 packet is encapsulated inside a packet of IPv4. Okay, then we have a little bit what we call translation. This one is a more common one. Okay, which is the network address translation 64, NET64, that allows the IPv6 enabled devices to communicate with the IPv4 enabled devices using a translation technique similar to the NET for the IPv4. Okay, so basically the tunneling and translation are for transitioning to the native IPv6 and should only be used where needed. So the goal should be native IPv6 communication from source to destination. So how exactly we represent the IPv6 address? So basically, the IPv6 address, they are created out of 128 bits of length, okay, and are written in hexadecimal. Okay, so means that 128 bits of binary, they written it in hexadecimal. Okay, so IPv6 addresses are not case sensitive, so you can use either capital letters or non-capital letters, lowercase or uppercase letters. Okay, the preferred format for writing an IPv6 address is what we have around 8 hexstat, means there are 8 sets, okay, 8 sets of 4 hexadecimal values, okay. A hexstat is called for one set of 4 hexadecimal value. So you separate this hexstat with a semicolon. Usually in IPv4 we have dot. So in this case in IPv6 we have semicolon. So if you look at the slide here, okay, you have the example of IPv6 address in the preferred format here. Okay, you have these values. Okay, this is 4 hexstat, this is 4 hexstat. Okay, you have total 8 hexstat that create one IP address. So this is 2 IPv6 address, okay, given here. Okay, so you can see that all of these values is hexstat, and each of them, okay, with total of, okay, each address representing 128 bit. Okay, so this one can go up until from 0 until F. Okay, here up until the end. So that's why you can see they are D, they are B. Okay, uppercase letter or lowercase letter, both are fine in the representation of IPv6 address. So because the IPv6 address is quite long, okay, where you have, okay, 8 combination of 4 hexadecimal numbers, so you have around 32 hexadecimal digits. Okay, so it's still quite long. It's as long as the whole binary of IPv4. So there are techniques for us to shorten the IPv6 address. Okay, so firstly we have what we call omit leading 0. Okay, so rule 1, which is you can omit the leading 0, reducing the space that you have to write for your IPv6. So like for example here in this case, okay, 01AB can be written as 1AB, 09FO can be written as 9FO, 0A00 can be written as A00, 00AB can be represented as AB. So they are eliminating the front zeros, okay, making the address shorter. Okay, so this rule only applies to leading zeros, not the trail zeros, basically not the zeros at the back. So at least you need to leave 1 zeros like this. Okay, 1 zeros like this. Okay, so you can omit most of the zeros in the front, but you have to leave at least 1 at the back. Okay, so next we have double colon. So a double colon, okay, can replace any single contiguous string of 1 or more 16-bit hexstat consisting all 0. So means that if the hexstat is all 0, okay, one hexstat is all 0, you can remove it and replace it with a double colon. Okay, for example here, you see that here is you have in this case you have 3 hexstat. Okay, you have 3 hexstat here. Okay, you want to remove from here until here. Okay, from here this location into this location. So you can remove here and replace it with a semicolon. Okay, double colon. Okay, so you can have a shortened IP address based on this rule. Then let's take a look at the types of IP address that we have. So basically, okay, in IPv6 we have 3 types of IP address. So we have the first one we call the unicast address, and the second one is the multicast address, and the third one is the anycast address. So the unicast address is uniquely identifies an interface on an IPv6 enabled device. Okay, so they means that they're representing an IP address of device. So multicast is used to send a single IPv6 packet to multiple destinations. So you have a lot of PC you want to communicate with. So multicast address, they help you to send to all these computer that you design, okay, when you have a designated multicast address installed for it. And then you have anycast. So anycast, okay, means that this is an IPv6 unicast address that can be assigned to multiple devices. A packet sent to anycast address is routed to the nearest device having that address. It's almost like multicast, but it's a kind of like multicast and unicast at the same time. So you have a lot of address, you have a lot of PC with the address, and when you send something, okay, only the nearest device will reply. Okay, so unlike the IPv4, IPv6 does not have a broadcast address. However, there is an IPv6 all nodes multicast address that essentially give the same result. So they have what we call an all nodes multicast address that that behave like a broadcast address in IPv4, but this one is designated in the IPv6. So IPv6, okay, basically they are separated into two parts, which means which is the prefix and the interface ID. Similar to the IPv4, you have the network portion and the host portion. So the prefix length is represented in slash notation. Okay, means that if you see an IPv6 address, you have at the back you have a slash 64. This representing 64 bit of the prefix. Okay. So, and it is used to indicate the network portion of an IP address. So the IPv6 length can range up until from 0 to 128. The recommended IPv6 prefix length for LANs and most other types of network is /64. Okay, so it is strongly recommended to use a 64-bit interface ID for most network. This is because tailored address auto configuration, okay, like for example SLEC, tailored address auto configuration. So they uses 64 bits for the interface ID. It also makes subnetting easier to create and manage if you utilize a 64-bit prefix. So we have, okay, several types of IPv6 unicast address. So most common that we can use is global unicast and link local address. So when you say about global unicast address, okay, this is similar to a public IPv4 address. So they are globally unique. They are internet routable addresses. So means that they will be provided to you by your provider. Okay. So other than that, we have one more common one that we use is link local address. Okay, so link local address, or usually they mention it as LLA, okay, required for every IPv6 enabled device and used to communicate with other device within the same local link. Means that it is for a local network. So LLA, which is the link local address, are not routable and are confined to a single link. So when you see a global unicast address, okay, so we talk about three parts, which is the global routing prefix, the subnet ID, and interface ID. Before this, we have the prefix, right? So we set the prefix, we have the global routing prefix and also the subnet ID. Okay, so in here, okay, the global routing prefix basically is the prefix or network portion of the address that is assigned by the provider, such as ISP, okay, to a customer or site. So the global routing prefix will vary depending on the ISP policies. So then we have the subnet ID. Okay, the subnet ID is the field that the area between is a field in the area between the global routing prefix and the interface ID. So this one is used by an organization to identify subnets within its site. So this one is given to the organization to set a subnet with. Then we have an interface ID. So what is interface? Okay, the IPv4, IPv6 as interface ID is equivalent to the host portion of IPv4 address. Okay, it is strongly recommended that in most cases of 64 subnets should be used, which create a 64 interface ID. Means that if you have a /64 network portion, you will have /64 interface ID. So basically, if you use a global unicast address, the first 3 bits, okay, in the first header will be represented as 001. Okay, 001. Next, let's take a look at the unicast address. No, not unicast address, it's a link local address. So an IPv6 link local address, okay, they enables a device to communicate with other IPv6 enabled device on the same link, and only on that link, okay, which means that subnet. Okay, so packets, okay, with a source and destination link local address cannot be routed. So every IPv6 enabled network interface must have an link local address. Okay, they must have an LLA, which is the link local address. So if an LLA is not configured manually on an interface, the device will automatically create one through something like DHCP. So IPv6 link local address are in the FEAT, okay, FEAT double colon prefix 10 range. Okay, they have FEAT, FE80 semi double colon with /10 range, /10 prefix range. Okay, so you see here, okay, in this case, router use the link local address of neighbor routers to send routing updates. So hosts use the link local address of a local router as a default gateway. So basically, it works like this. So if you talk about the global unicast address and link local address, okay, the configuration involved might be, if you look at your router, okay, when you configure it, you will be configuring it under interface. Okay, interface gigabit ethernet 000. Okay, other than that, you have IPv6 address 2001 this, no shutdown. So usually if IPv4, you just put in IP address, right? So in this case, you have what we have here, which is IPv6 address. So you can set up your IPv6 address here, okay, within this kind of window inside the Windows host. Okay, so you can see that you have to insert the IPv6 address, you have to insert the subnet prefix and the default gateway of your router. Okay, so and then when you want to configure, okay, a static global unique address configuration of a link local unicast address, in this case, okay, you see that you have interface. Again, this is this IPv6 address. Okay, this one is a link local unicast address, which is FE80, okay, double colon 1 colon and 1, which is this one is a link local. If you look back here, okay, you don't need to put in anything in case it's a global unicast address. Okay, and this one you have to insert a link local point. Okay, so you have in order to configure this manually, okay, it lets you create an address that is recognizable and easier to remember. So link local address can be configured manually using the IPv6 address with link local command. Okay, to summarize it, okay, the same LLA can be configured on each link as long as it's unique on that link. Means that you can use the same address again in another network as long as it doesn't connect to the network before. It's the only one that you use inside the network. Okay. So next we have dynamic addressing for IPv6 global unicast address. So device, okay, dynamic addressing for IPv6 global unicast address, they involve RS and RA messages. What RS and RA? So device obtain the global unicast address dynamically through Internet Control Message Protocol, which is the ICMP messages. Okay, so router solicitation, which is what we call RS messages, are sent by host device to discover IPv6 route. And router advertisement messages are sent by routers to inform hosts on how to obtain an IPv6 global unicast address and provide useful network information such as network prefix and network prefix length, default gateway address, DNS addresses, and domain name. Okay, The router advertisement can provide three methods of for configuring an IPv6 global unicast address, which is under slug and slug with stateless DHCP v6 server and stateful DHCP v6, which is without the slug. Okay. So let's take a look at the first method, slug. Okay. So SLAAC slug. Okay, you have a prefix and interface ID here. So from the router advertisement messages, okay, router advertisement message, so created by client device. Okay, the interface ID is created by client device EUI64 random 64-bit number. Okay, so slug allows a device to configure a GUA, okay, global unicast address, without the service of DHCP v6. For IPv6, we have another version of to generate the IP address, which is slug. So device obtain in the device will obtain the necessary information to configure a GUA from the ICMPv6 router advertisement messages of the local router. So the prefix is provided by the router advertisement, and the device uses either the EUI64 or random generation method to create the interface ID. So in case of slug with stateless DHCP, okay, a router advertisement can instruct a device to use both slug and stateless DHCP. Okay, they can use both. Okay, so slug, okay, the RA message suggests device use the following. Okay, select to create its own IPv6 GUA and the router link local address, which is the router advertisement source of IPv6 addresses for the default gateway address, and a stateful DHCP v6 server to obtain the GUA, DNS server, domain name, and other necessary information. Okay, so here you have RS message towards the router and the reply of the RA message towards the PC and the DHCP v6 solicited, okay, with the stateless DHCP v6 server. So dynamic addressing for IPv6 global unicast address. Okay, you have this EUI64 process, okay, and also we have another one which is randomly generated. So when the router advertisement message, okay, is either slug or slug with stateless DHCP, the client must generate its own interface ID as well. Okay, so the interface ID can be created using the EUI64 process or a randomly generated 64-bit number. Okay, so this one is according to what we have, okay, when the RA message is being sent. Okay, the IEEE basically they define the extended unique identifier or modified EUI64 process which perform the following things. Okay, here you see that 16-bit value of FFFE in hexadecimal is inserted into the middle of the 48-bit Ethernet MAC address of the client. Okay, this one is 48-bit Ethernet MAC address. So the 7 bits of the client MAC address is reversed from binary 0 to 1. Okay, so let's take a look here. So here, if you see that the 7-bit, okay, means that it's within the E. Okay, it's within the E. So this one will change, okay, from the MAC address into EUI64 interface ID. You see that FFFE is inserted here. Okay, so the way it's inserted here, you just push back, okay, between the 47 and 75 and insert the FFFE. So when we talk about the randomly generated interface ID, okay, if you want to check it, okay, you can just type in the ipconfig. Okay, you see ipconfig inside your Windows, and you will see that this IPv6 address. Okay, so depending on the operating system, okay, a device may use a randomly generated interface ID instead of using the MAC address and EUI64 process. So beginning with the Windows Vista, okay, Windows use a randomly generated interface ID instead of one created with EUI64. And in order to ensure the uniqueness of any IPv6 unicast address, the client may use a process known as duplicate address detection, and this is similar to an ARP request for its own address. If there is no reply, then the address is unique basically. So we look at dynamic addressing for IPv6 link local address. So a little bit different than the global unicast address. Okay, for link local address, you have, okay, basically all IPv6 interfaces, they must have an IPv6 link local address. So like IPv6 global unicast address, link local address can be configured dynamically. So the figure like here, they show the link local address dynamically created using this FE80 double colon prefix 10, okay, and the interface ID using the EUI64 process or a randomly generated 64-bit number. And then we have, okay, in case for Windows, so operating systems such as Windows will typically use the same method for both a select created global unicast address and a dynamically assigned local address. So if you type in ipconfig, okay, here in Windows, you can see that this, okay, link local address and IPv6 address, okay, which involve the EUI64 generated interface ID. In case you put in a random 64-bit generated interface, okay, so add it back, okay, which is under the interface ID, all of them is inserted randomly based on the command that you have given. So when we say about the dynamic LLAs, okay, when we want to integrate it with the Cisco routers, okay, you can just check them, okay, like for example, show interface gigabit internet 000, okay, so you can see that the message is that hardware is this, address is this, okay, and if you summarize it to be a little bit short, like you want it to summarize, okay, show IPv6 interface brief. Okay, when you do it like this, okay, you will see that this information is provided here. And when you want to verify the IPv6 address configuration, you can look into show interface gigabit internet again. Okay, you can see that the hardware is this, address is this, and show IPv6 interface brief, and you will see it inside displayed like this. So it's a little bit similar than before, okay, when you want to verify it. So next is IPv6 multicast address, okay, so we have an assigned IPv6 multicast addresses, okay, so IPv6 multicast addresses, they must have a prefix /8 with the front one FF00 with double colon here. So there are two types of IPv6 multicast address. So well-known multicast address and solicited, okay, node multicast address. Okay, multicast address, they can only be destination address and they cannot be a source address. So you cannot have multiple computers sending to one PC. So we look at well-known IPv6, okay, they are divided into two groups. So you have FF02, that's double colon 1, all node multicast group, and you have FF02, double colon 2, which is all routers multicast group. So in FF02 double colon 1, okay, this is a multicast group that all IPv6 enabled devices join. So a packet sent to this group is received and processed by all the IPv6 interfaces on the link or network. Okay, so when we talk about the all routers multicast group, okay, so this is where a multicast group that IPv6 router join. A router becomes a member of this group when it is enabled and as an IPv6 router. Okay, so with the IPv6 unicast routing global configuration, okay, with IPv6 unicast routing, okay, in global configuration command, you can get access to this group. Okay, so when we talk about solicited node, okay, for the IPv6 multicast, example, you have this PC. Okay, so a solicited node multicast address similar to the all node multicast address or solicited node multicast address, they are mapped to a special internet multicast address. Okay, so this one we see that the internet destination MAC multicast and IPv6 here. Okay, destination IPv6 solicited node multicast. So in this case, okay, so they is mapped into a special internet multicast address. Okay, the internet NIC can filter the frame by examining the destination MAC address without sending it to the IPv6 process to see if the device is the intended target of the IPv6 packet. So when they send this, okay, my internet NIC determine this multicast not for me. My internet NIC determine this multicast not for me. My internet NIC determine this multicast is for me. So this is where involvement with the multicast occurred. So you see from this explanation only you can predict what kind of problem you might have. So for example, if some PC here pretend to be this PC, you can have a problem with the spoofing. Okay, so next let's take a look about how to subnet an IPv6 network. So basically when you want to subnet, okay, IPv6 was designed with subnetting in mind already. Okay, the separate subnet ID field, okay, which is after the global routing prefix. Okay, you have the 16-bit for subnetting. Okay, so they used to create this subnet. Okay, the subnet ID is the area. The subnet ID fields, okay, is the area between the global routing prefix and the interface ID. So you have a 16-bit to determine a subnet. So when you see, okay, when you start a subnet, okay, for example, this one given 2001 DB8 ACAD/48 global routing prefix with a 16-bit subnet ID. So means that from here, okay, after the ACAD here, okay, you will have a 16-bit subnet ID. So this one allows 65,536, okay, /64 IPv6 address to /64 subnets. Okay, so the global routing prefix is the same of all the subnets. The front is the same. Only the subnet ID is different, okay, because they are separated into, okay, 65,536 subnet. So next, okay, so here in this case we have example topology that requires 5 subnet. So one for each LAN as well as for the serial link between R1 and R2. So the 5 IP subnets were allocated. So with the subnet ID field from 0001 through 0005, each 64-bit subnet, each /64 subnet will provide more address than will ever needed. Okay, means that this one, if you look at one, will be a lot of PC, smartphone, or anything involved within this branch. Okay, so because they are using IPv6 protocol. Okay, so they usually doesn't pay attention much on the limit of the IPv6 address because they are a lot. So in order to subnet, okay, well, once you have subnet, you have to configure all those network inside your router. So in this case, you have to divide, okay, for example, gigabit Ethernet 000, this is the first subnet. This is the second subnet. This is the third subnet. Okay, it's up to you of how you're going to do the networking. So I guess that's all for today. Okay, thank you very much for joining my class and continue joining my class. Hopefully this class will be continue to benefit you in your studies, and I hope that you guys can stay with me up until the end of the course. And again, I would like to thank all of you for subscribing to my channel, for the likes that you have given me. I really appreciate it, and I hope to see you soon in my next video. So that's all for today. I see you guys later. Have a nice day. Bye bye.